This is the walkthrough video for PCTC 2022, round 2, question 9, full coverage. So we're essentially given a certain amount of rectangles in a given format, and we need to figure out where do all of these rectangles overlap, and then we need to calculate the area of this overlapped region. So for example, in our example input, we have these number of rectangles, and we see the point where all of them overlap are these 10 cells here. And so the answer to this problem would be 10, because that's the size of the overlap. I really like this question because there are a few different ways of doing this, but if you think through logically to try and find an efficient way, you can end up getting code that's only like 10 lines long, I think. And that's just quite cool. It's always cool having short code, especially for a question 9. Okay, let's dive straight in. So what I'm going to do is I'm going to process our inputs as we get them. So I'm not going to take in all the inputs and then process them. I'm going to process them as we get them. So I'm going to have an overall for loop that all of our code fits into. And this for loop is going to run as many times as our initial input. So as many times as that number, because that's how many inputs we get. And now let's actually take in our input. And the problem calls them x, y, w, and h. So that's what we're going to call them to. X, y, w, h. That's going to be our inputs are in inputs.split. And so this line of code basically just, for example, if you've inputted this entire line of numbers, it extracts each of those integers and assigns them to the variable x, y, w, and h. Okay, now we get to the harder bit. Now is where we do some processing. And you're going to see why I'm going to do it this way a bit later on. But essentially, I'm not going to store. So essentially, what I want to do is I want to, as I take in every new rectangle, I want to store the new coordinates of the most overlapped rectangle. For example, let's say my first rectangle is that. Now let's say my second rectangle is that. Well, the only things that are worth storing are like, is that rectangle, right? Because we want to find the region where every single input rectangle overlaps. And so there's no point storing anything else that isn't already in overlap. So we're only going to store the overlaps. And now, for example, let's say they input this rectangle. Now instead, I only want to not store all of that blue bit. I want to store that blue bit because that's the bit where every single input so far overlaps. So that's what we're going to do. But of course, when we only have one rectangle, so our very first input is just going to be one rectangle. Like that's the entire thing. And so for our very first input, we are simply just going to store the entire rectangle, and we're not going to bother checking where the overlap is. And so to check that, let's say if I is equal to 0, and this is basically saying if this is the very first time we're running this loop, then all we want to do is literally just store our input because we haven't got any overlaps yet. But actually, I'm going to store in a different way to how the question gives it to us, which might be slightly confusing, but later on it's going to be way, way easier. So the question gives it to us as the x and y coordinates of that at the bottom left corner, as well as the width and height. But I want to store it as, yes, the x and y coordinates of the bottom left, but also the x and y coordinates of the top right. So I'm not going to store the width and height. I'm just going to store the bottom left and the top right coordinates, which is effectively the same information. It just should make processing a bit easier. So to store that, let's call the bottom left coordinate, like the bottom left A and the top right corner B. And so the x value of the bottom left and the y value of the bottom left, and the x value of the top right and the y value of the top right. And we're going to say these are equal to initially our input value for bottom left, and our top right corner is going to be equal to the bottom left x plus the width, and our top right y value is going to be the bottom left y plus the height. And so now, I mean, that's our rectangle done, right? And so we might as well just continue this for loop, because for our very first input, we just want to store the rectangle. Let's just continue. But if it's not our first input, then let's run the actual code or write code that processes all of our inputs so far, or processes that input, and it decides what the overlap region is, and therefore only stores the overlap region. Okay, so at this point on line 8, for example, this line is only ever run after we've already got first input. So we've already defined these 4 variables. We've already got a base rectangle to work off, as well as the new rectangle we've just inputted. So now the question is, how do we figure out the overlaps? So let's draw a new rectangle down here, like that. So let's say this is our very first rectangle we've inputted. This is our base rectangle. And now let's say our brand new inputted rectangle is that one. And we obviously want to only figure out the region of that rectangle. So how do we do that? Well, if we look at our base rectangle, then we've got so we start off with these two values in purple, and we're also given obviously the relevant values of our brand new rectangle. And so we want to calculate these two coordinates that I've circled in purple. Obviously, in this case, this top right coordinate is one we already have, but that's not always going to be the case. For example, if our inputted rectangle was here, then we don't have either of these two coordinates, and so we need to make sure we're considerate of that case. Okay, so how do we calculate these coordinates? So how do we figure out what they are? And that's so essentially the bottom left coordinate is going to be whatever the biggest y and the biggest x we have so far is, right? So we are simply given in the code these two green coordinates, and whatever the biggest x and the biggest y is, that's going to be the bottom left of our brand new rectangle overlap, right? No matter what our rectangle is, the bottom left is going to be the bottom left of our new overlapped rectangle. And so that's the easy bit. Now the hard bit is figuring out what on earth is the top right coordinate going to be, because that's the coordinate we want to store as well. And how do we figure that out? Well, we need to essentially figure out whether the top right of our current rectangle is bigger than or smaller than the top right of our inputted rectangle, right? So let's redraw all of this. It's quite difficult to explain because there are so many things to draw, but let's try. So let's say that's the rectangle we start off with. That's the one we already have. That's our very first rectangle we've inputted. And now let's say this red rectangle is the new one that we've inputted, and we want to figure out the overlapped region. Well, if it's there, then obviously the overlapped region is going to be the top right corner of that's going to be whatever the smallest x and y coordinates are, and the bottom left corner is going to be whatever the biggest x and y coordinates are, right? So we're almost like working in that direction. Actually, no, we're staying there. So yeah, so we're almost going inwards, right? We want to find the biggest x and y for the bottom left and the smallest x and y for the top right. And I mean, there's not much more I can do to explain this, other than maybe pause the video, have a think about it. But this is essentially the checks that we need. And to code that's actually relatively simple, at least for the bottom left, because all we have to do is we have to say ax, which is our overlapped bottom left x coordinate, that's going to be equal to the maximum of whatever our inputted x is, as well as ax itself. And the same logic applies for ay. So it's going to be y and ay there. And so all of a sudden, in those two lines of code, we've already found the new bottom left coordinate. Now the top right coordinate, that's going to be slightly trickier, but again, we can apply the same logic. But instead of finding the maximum coordinate, as we said, we want to find the minimum coordinate. So it's going to be the minimum between what we already have, of course, which is bx. And now this is the slightly harder part because we're not given the input. We're not given the coordinate of the inputted rectangle of the top right. We're only given the width and height, and so we have to calculate that ourselves. But of course, it's basically the same logic that we had up here, very nice and simple. So we can just copy paste that down there. And now this line of code, we can again basically just copy it, but in this case, deal with y instead of x. And that's pretty much it, right? This is all of our logic code. This means by the time this for loop is run, we found the rectangle that is overlapped with every other single rectangle. And we've got the coordinates at the bottom left and the coordinates at the top right. And so all you have to do to get the answer is figure out what the area that is and print that out. So the area is going to be the height times the width. Now, what's the width going to be? The width is going to be bx minus ax, and the height is going to be by minus ay. And we should be able to just print that out and run that. So again, this code is quite slick, and it almost seems a bit too simple, but it's also a bit too difficult to understand. So if you don't understand it, check out the description. You can copy the code in the GitHub repository, and you can always just have a play around with it, print stuff off. Like maybe you're confused about what these are, then you can, for example, print them off, and then as the code runs, you'll be able to see what's printed off, and that could help you try and understand what the code is doing.